Okay, section 3.5, the grade 9 academic course, collecting like terms. So we learned what terms was in the last lesson, and of course that's just one part of a polynomial or expression where you have letters and numbers multiplied together. And I say CLT, just that's the cheap way of saying collect like terms. So what's the thing we're looking to be able to do? Simplify. Simplify means take something that's complicated, right? Make it easier. And that's our goal. Everything we're going to do today is try to make things easier to see. Well, once you identify what like terms are, then we're going to simplify them. So, of course, Charlie, very happy out on the grass, and he likes simplifying. He's a simple kind of dog. Okay, so when I say the term like term, what I mean is they have to have identical variables, and it not just identical, like not just the x or the y or the a, but the exponent must be the same. Okay, so if I'm looking at an example, 4x and 2x, they're what I call like terms. The exponent, the variable is the same. 4x and 2a, not like terms, right? A and x. 4x squared and 2x squared are like terms because they have the same exponent. So here, 4x squared and 2x, not like terms, and that's really important to catch, okay? If they have different exponents, you can't, they're different. They're two different, they're not like terms, and that does affect how we simplify later, okay? So this just a simple example, identify the like terms. So the things that are like, this one, and this one. It's okay that this one's negative, that doesn't matter. All that matters is the variable and the exponent, which is 1, are identical to each other. Variable and exponent are identical. This one, 4a squared and negative a squared, right? Because the a squared b variable is different, right? The variable is not identical. 2b, obviously. 2b in this, not the same because it doesn't have an a squared. It has to have the exact same variable and the exact same exponent. Okay? But a squared b and 0.5 a squared b also like terms, right? Because they both have a squared and they both have b without a square. Identical. Doesn't matter that the number in front's different, who cares, that they're still like terms because the variable and the exponent's identical. Alright, so when we collect like terms, what does that mean? We want to simplify an expression. You do that by collecting the like terms. And what I mean by that is, you take this 3-term expression and you can make it a 2-term expression. And the question asks us to identify what type of polynomial. So the strategy, group. And by group, I mean take the ones that have x's and put them beside each other, and the one that doesn't have an x and put it by itself. Okay, so you group and then you can add or subtract like terms only, and you add or subtract just the coefficient, the number that's in front of it. Okay, so 6x plus 5y, because you have 2x plus 4x. You add the number, 2 plus 4 gives me the 6, and the 5 I can't do anything with. Okay, so this is a binomial, even though here, this is a binomial. You say, no, Miss Donna, it's a trinomial. But because you can simplify it further, it's really a binomial. Okay, let's look at another example. This time I've got 5x plus 4y, so I got a group, and by grouping again, I'm going to take the terms that have the same, that are like terms, and put them beside each other. Now I want you to be, this is maybe the most important thing, right, that we do. You need to know that the number or the sign in front of the term goes with it. Look, this here is a negative x. This negative has to come with it. It is the most important thing that you do. Well, maybe not in life, but when collecting like terms, it's so important that you put the same sign. So as I rewrite this then, right, 5x, I want to bring the x parts all together and the y's all together. So the whole negative x comes here. That's why that is negative. It's because it came with the x. Okay, then you have 4y, and again, minus 2y. The minus came with the 2y. Whatever sign is in front of a term stays in front of the term, and that's just so important. So now when I do the, I'm going to add, what does it say? Apply integer rules to the coefficients only. 5x minus x. You have to remember that that's the same as minus 1x. The 1 is implied, right? So that's 5 minus 1, which is 4. And then 4 minus 2 is 2. Okay? This one's big, but it's really the same thing. And binomial again, 2 terms. This one's big. Let's go through why it is what it is. Okay? First step I did here was collect the like terms, and I want to remind you that, or group the like terms. I put, it has to be the same exponent. So 2x squared and negative 6x squared. Again, the negative came with it. Okay? And you got the minus 5x, so this negative came down here. The minus 4x, that one came down here, right? The same sign has to stay in front of it. I have plus 8, so that plus went over here, and plus 2, because this plus went here. Okay? So the sign goes with whatever term comes after it. So anyways, I grouped, and now 4x squared minus 6x squared is minus 4, so I'm just taking 2 minus 6 is the minus 4. Okay? And then you just keep the x squared, right? So you add or subtract the number and just keep the variable as it was. Minus 9x because I have minus 5 minus 4. Okay, so this whole, you take the sign in front of it, minus 5 minus 4 is minus 9. Right, I had a bad team to begin with. I took away 4, so it got even worse. And then plus 8 plus 2 is all positive, so it stays positive. And this is a trinomial. Even though it's a, look here, it looks like 1, 2, 3, 4, 5, 6, 6-term polynomial. It's not. One more. Notice, by the way, when I rewrote it here, I followed the rule again, right? Highest degree term first. So I've got 2a squared, so I brought again the positive. I don't have a positive written there, but I could. It's implied, right? Positive's there. So that's this positive right here. There's no other terms with a squared, so I'm just going to leave that. And I'll go on to the next. I could go to b's, but I'll stay with the a's next. The next highest term is 1, degree 1. So I've got minus a. And I've got this. See this, by the way? Again, it's implied that that's a plus 3. It doesn't say plus 3, but it's implied. So when I put this down here, it's plus 3a. Okay? This minus a comes from here. This minus 8b is because of this sign here, came over here. And that's sort of getting all my terms with variables. Now I'm out of terms with variables, so I'll write the minus 5, right? That followed right there. And my plus 1, that came right here. So the sign just follows with the number that's after it. Then after I've grouped, now I'll say, okay, 2a squared, I can't do anything with it. It's on its own. 3a minus 1a is 2a. 3 minus 1 is 2. The 8b is nothing to be added or subtracted to, so it stays. Minus 5 plus 1 is minus 4. So now I have a 4-term polynomial because I have 4 different terms. I can't do anything else with it. So that's it. Again, make a note of what questions you have, and in the class you can start working on some problems.